Today's lesson is about simplifying algebraic expressions. In order to simplify an algebraic expression involving addition, we're just going to look at addition, you must be able to combine like terms. For example, let's say I want to combine 2x squared plus 4x squared. Alright, what makes this a like term is that you're looking at the variable. They both have an x, and they're both raised to the same power. They're both raised to the second power. So what you want to do is you're going to add the numbers. What this is called is the coefficient. And you're going to always add the coefficients. You never add the exponents. The power it's raised to is called the exponents. You're just going to add the coefficients. You don't add the exponents. Alright, so if you have 2x squared and we're adding 4x squared, you just add the coefficient. So 2 plus 4 is 6. That means you have 6 of them. The coefficient tells you how many variables you have. It stands for quantities. That means you have 6 x squareds altogether. Alright, for example, you may be asked to simplify an expression like this. 2x plus 3x squared plus 4x plus 5x squared. First thing you want to do is put together like terms. Because we have all addition, I can move it around because addition is commutative. Doesn't matter the order I add. So I'm going to put the x squareds together first. I have a 3x squared and I have a 5x squared. And then I have a 2x and I have a 4x. Again, just add the coefficients. Do not add the exponents. So 3 plus 5 is 8. So it's going to be 8x squared. I have 8 of the x squareds. And I have 6 of the x's. This is as far as I can go. These are the same variable, but it's not the same term because this is raised to the second power. So it's 8x squared plus 6x. As far as you can simplify. Alright, now when you have subtraction, you have to be a little careful because the order does make a difference because subtraction is not commutative. So one way to do this is to change subtraction over to addition because of this rule. Any difference between any number is the same as the sum of the negative of the number to the left. So a minus b is the same as a plus negative b, where a and b are any two numbers. Alright, so look, I'm going to apply that here. I'm going to put 2x squared. I'm going to put plus though, and I'm going to put a negative 3x here, plus 2. Now notice I have a subtraction sign in the parentheses. That means you have to change the sign of every term inside the parentheses. So I'm going to put a negative, or I can put a plus negative x squared. And this becomes plus 2x. And then plus negative 1. And now I have all addition. And I can just add the like terms. So I'm going to put 2x squared. I'm going to add that to the other x squared term. I have a negative x squared here. And I have a negative 3x here. I'm going to add that to 2x. And this is what I call a constant, a number that doesn't have a variable attached. So I have a 2. And I'm going to add that to a negative 1. And you just simplify it. So 2 plus negative 1, that's like 2 minus 1, that's just 1. So 1 times x squared is just x squared. And then you have plus, we have negative 3x plus 2x. That's the same as negative x, because that's negative 1x. And 2 plus negative 1 is the same as 1. Now, usually we write it like this. Put x squared. Instead of plus negative x, I just put minus x. And then plus 1. And that's it. Alright, what do you do about multiplication? When simplifying expressions involving multiplication, you can distribute. That means to share. For example, if I had 2 times x plus 1, we're going to multiply each term in the parentheses by 2. I'm going to distribute the 2. So I'm going to say 2 times x plus 2 times 1. So it's just 2x plus 2. Alright, so for example, it says simplify, and we're going to multiply x to those terms in the parentheses. You want to note that when you multiply powers of the same base, that's when you change the exponents. So you're going to have x times x squared minus x times 2x plus x times 1. Remember, we're not adding, so when you multiply, this is like x to the first power here. You add the exponents when you multiply powers of the same base. So this becomes x to the third minus 2x squared. That's like 1 plus 1 plus x. And that's as far as you can go because these are all unlike terms. And what do you do if there's 2 binomials? Let's say multiply 2x plus 1 times x plus 2. You can distribute, and then some people teach FOIL. But you can use geometry in something like this. You can make a square. I have 4 squares. If you take each of these terms, let's say this has a length of 2x from here to here. And this is a 1 by 1 square. Let's say this is x and this is 2. What you want to do is you're going to multiply the areas. Let's say this is 2x by x. That gives you an area of 2x squared. Remember, length times width for the area of a rectangle. This is an x by 1 rectangle. So 1 times x is x. This is a 2 by 2x, so that's going to be 4x. And then this is a 2 by 1 rectangle, so this becomes 2 times 1, that's 2. And you just want to add the like terms. The only like terms are the x terms. So you have 2x squared. 4x plus x is 5x. And then plus 2. And that's as far as you go. When simplifying expressions involving division, you can also distribute. For example, I can have 2x squared plus 2 divided by 2. What I can do is this. That's the same as 2x squared divided by 2 plus 2 divided by 2. 2 divides into itself once, so I'm left with just 1 times x squared, x squared. 2 divides into itself again once. So I'm left with x squared plus 1. You can do that with variables as well. If I want to simplify this expression, x cubed minus 2x squared plus x divided by x. That's the same as x to the third power, or x cubed, divided by x, minus 2x squared divided by x plus x over x. It turns out there's a pattern when you divide power to the same base. Instead of adding the exponents, you can subtract the exponents. And the reason why is, remember, this is repeated multiplication. That's like x times x times x. And you're dividing an x from there. So you're left with x squared. But the quickest way to do that is simply to subtract the exponents. So that's like x to the 3 minus 1. And this is 2x to the 2 minus 1. And 1 minus 1 is 0 here. So that's x to the 0. And the definition of that is 1. Or you know that x divides to itself one time. So you're going to wind up with this as an answer. You have x squared minus 2x plus 1. That's how that works. Sometimes you may get long division. I have a binomial here. I have a two-term polynomial, and I'm dividing that into this trinomial, 2x squared plus x minus 3. In that case, you're going to have to use long division. So I'm going to put x minus 1. I'm going to divide that into 2x squared plus x minus 3. Alright, this is not as hard as it looks. What you're going to do is forget about the minus 1. Just look at the 2x squared and the x and say what times x is 2x squared. And if you said 2x, that's correct. 2x times x gives you 2x squared. You always want to match this first term. So you're going to get 2x squared, but you have to multiply the 2x times the negative 1. So you're going to wind up with minus 2x. And the rule of division is you have to subtract that which you multiply up top here. So look, watch this. This is a minus, but you change this to plus. This always should cancel. So that's going to be 0. 2x plus x is 3x. Minus 3. You've got to bring the minus 3 down. And you continue up here. What times x is 3x? Well, just 3. 3 times x is 3x. And 3 times negative 1 is negative 3. And again, you got to change the sign, which gives you a remainder of 0. So the answer to this is just 2x plus 3. That's your quotient. This concludes the lesson for today.